Our next presentation is Arizona DOT Deck Preservation Treatments. Please welcome David Benton, the Bridge Design Manager for Arizona DOT.
All right, good morning, everyone. Wanted to take this time and give you a little bit of a brief presentation about our overlay program and kind of the evolution and the lessons learned with our different treatments. Basically, our bridge deck overlay program consists of three types of overlays. We perform hydrodemolition with the use of a microsilica silica fume overlay. We've also used polymer epoxy thin bonded overlays and polyester polymer concrete overlays. And this presentation will go through each of those types of overlays and some lessons learned. So first of all, don't do this. Don't pick a bridge that you think could survive a hydrodemolition. The good thing about this is it did its job. It got rid of all the bad concrete, for sure. This was a T-girder bridge on I-40 where we had success with hydrodemolitions on previously T-girder bridges within decks 7.5, 7 inches, and we felt confident with that. Unfortunately, in this case, this bridge was in much worse shape. So we got rid of all the bad concrete and ended up with the superstructure replacement. Some of our other bridges on I-15, we were one of the first ones where we experimented or utilized a microsilica overlay. This particular stretch of I-15 is unique. It's very hard to get to. You have to go out of the state of Arizona just to get back into it. And we have multiple bridges that were greatly efficiently designed back in the late 1960s, early 70s. With fracture critical bridges, large decks, but two girder systems. So we couldn't necessarily replace the decks, so we used microsilica overlay. So this is the I-15 Virgin River Bridge number 3. This wasn't a T-girder bridge that we had success in terms of not making Swiss cheese out of it. The deck condition here was in 04 after the microsilica overlay. You can fairly see some cracking in the overlay faintly there in 04. But 9 years later, this is what it looked like. Some of the things that we utilized back then was, one, when we first started our microsilica overlay program, we utilized only 1.5 inch of an overlay. Wanted to replicate basically the cover that was designed at that time, and found that probably wasn't the best case. So the lessons learned from that approach was, one, increase overlay thickness to 1.5 inches, from 1.5 inches to 2.5 inches. Make some additional improvements to the specification, having requirements for night placements in hot weather, having calm wind conditions, which is challenging in that gorge area, improving the evaporation rates, adding microfibers, and increasing the cure period to 14 days. And we also revised the deck repair provisions. One of the things that we had in our specification at the time was that if the deck did exhibit cracking, then contractor, please put a methacrylate sealant on it. Well, there wasn't any provisions to basically prevent them from saying, well, it's going to crack, we're just going to put a methacrylate sealant on there. So we made provisions where we don't want that necessarily to happen. We don't want to have to put a methacrylate overlay on or seal on there. So we made some additional improvements there, as well as a field demonstration. So this was the second install on the Virgin River Bridge number 3, and it's performing really quite well now, currently in its condition, with the improvements of going to 2.5 inches and the deck specifications. Another bridge on I-15 is a fracture critical bridge, number 5 northbound, southbound. Here again, on the southbound, we performed a microsilica overlay, and this picture is from 2004. Again, 8 years later, again with the 1.5 inch cover, we experienced this type of cracking. So with that, we basically went and did additional improvements like we did on number 3 with the second overlay on that bridge. Alongside it, its twin, The northbound, we, at that time of the first of the microsilica overlay, we did a epoxy overlay on that bridge and was quite successful. That epoxy overlay is performed quite well and is continuing to perform quite well on that bridge. In addition to that, another successful overlay was with the thin bonded overlay was the I-17 Little Squaw Creek. This gave us confidence that we're choosing the right bridges to perform these overlays, and they're quite successful. The I-10 Gila River Bridge epoxy overlay did quite well as well. But then we started to see some problems. This particular bridge is the SR-79 Gila River Bridge, which again was a very long span bridge, didn't have the funding to perform deck replacement, wanted to help keep that bridge preserved, and went with the approach of performing an epoxy overlay. Unfortunately, it had a lot of spall repairs. In essence, basically the spall repairs failed and not necessarily the epoxy overlay. In addition, some of our epoxy overlay in this example was the SR-89A Hell Canyon, where we had some surface prep problems and the overlay failed. And again, this particular bridge did exhibit quite a bit of patching with the epoxy overlay project. Another example was the I-40 Willow Creek Bridge, number 3. This is a fracture critical bridge as well, two-girder system where we couldn't necessarily get away with the deck replacement, and we wanted to keep the bridge open and in service, so we decided to place an epoxy overlay on that. Unfortunately, again, a lot of deck repair involved with that project. So the lessons learned from Bridge Group was, well, let's take a step back. We had some early on successes with our epoxy overlay projects, but we want to reevaluate, are we choosing the right bridges with the right conditions to place this type of overlay on it. Not all bridge decks and their conditions can accept an epoxy overlay. Don't pick bridges with excessive spall repair needs, and concentrate on surface prep. So in lieu of the polymer epoxy overlays, we went forward during that time and moved on with the polyester polymer concrete overlays, but taking the lessons learned from the epoxy overlay program and improving our bridge selection and condition for this application. So we decided to try that out on the I-40 Willow Creek, where we removed the epoxy overlay and placed a PPC overlay. Unfortunately, we had some issues with some of the deck preparation and not all of that epoxy being removed. And as you can see here, we had some failures with the bond as a result of that concrete being placed. Had some type of chemical reaction there with some of the epoxy there and just didn't set up well. We've had some great successes. This is the I-40 Big Gem Wash. This is a slab bridge where we've done a 3/4 inch mill and a 3/4 inch placement of PPC overlay. The I-40 Babbitt's Tank Bridge, again, a slab bridge with a PPC overlay. So a lot of lessons learned in terms of us choosing the right bridges for the right overlay program. And in addition to that, we've also tried some new things with our PPC. This is a brand new bridge replacement with the GRS IBS system, where we did an accelerated bridge construction with adjacent box beams with the polyester overlay. This has been successful and has served us well so far. And here's another picture of the I-40 Meteor City. So where we are today, a majority of our low cover bridges using microsilica have been accomplished. The new spec is performing very well. Majority of our deck preservation program is currently using and scoped to use PPC overlay. And we have lifted the suspension of the thin bonded epoxy overlays and have utilized that on 2 projects to date. And sometimes we can't preserve the bridges that we have, and we have to move forward with the bridge replacement. So with that, a very short presentation, but I wanted to give an overview and open it up to any questions you all may have.
This might be in the weeds a little bit, but for your microsilica rigid overlays, what type of finishing equipment do you use on that? Is it the roller drum type or a Vibra screed type, or do you know?
Yeah, I believe it's a screed machine. So we won't use anything like a Texas screed or anything like that. So I believe it's just basically your typical bridge screed equipment with the bidwell.
The Meteor City Bridge, how thick of a PPC overlay did you do on that? And are you guys seeing any reflective cracking from the box beams up through the PPC overlay?
Yeah, great question. We did a minimum 2.5 inch overlay on that bridge. We understood that there could be some reflective cracking with the adjacent box beams, so what we did is we kind of gave it a little bit more of a stout connections with the post-tensioning rods. So our typical spacing for that span would have been maybe two per, for that single span. We bumped it up to 3 in order to try to minimize that reflective cracking, but we haven't had any issues with that.
Yeah, Dave, really good presentation. Thanks so much. But question for you, you said the hydro demo and microsilicas, you bumped that up to 2.5 inches. What are the thicknesses that you're using the epoxy concrete overlay and polyester polymer concrete overlays? What are those thicknesses?
So the thin bonded is the typical 3/8 inch thickness of overlay, and the PPC overlay is a minimum of 3/4 and 1 inch.
What's the difference in cost between the PPC and the epoxy per square foot?
Oh, that's always the cost question. I don't necessarily know the actual difference, but the PPC overlay is more expensive from a square yard perspective than the thin bonded epoxy overlay.
All right, how about a big thank you for David and that great information from Arizona.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.